Hi guys, this is the video for chapter 6, lesson 5. So in chapter 6, we have looked at quadrilaterals and specifically parallelograms and rectangles. So before we look at today's lesson, let's review some of the qualities we know to be true of parallelograms. So if I were to fill out part of these sentences, see if you can fill these in. Okay, so for this one, parallelograms, opposite sides are, what do we know to be true? For a parallelogram, they are congruent, right? So let's fill that out here. Opposite sides are congruent. Opposite sides are parallel, right? So if you look at a parallelogram, opposite sides are the same length. They're also parallel. Opposite angles are congruent. Consecutive angles, meaning angles that are just next to each other, these two, they would add up to be 180. So they are supplementary. And how about diagonals? We looked at diagonals. What's something that we know to be true about their diagonals? Now, they're not the same length, but we know that if they cut through each other, they intersect, they're going to split each diagonal into consecutive congruent parts. And so diagonals, we call that, they bisect each other. And if you have your flip book, you can look back on this and see these qualities, okay? Looking at rectangles. Now, rectangles have all the qualities of a parallelogram. So all this is true for a rectangle, but there's two more specific things. So rectangle looks like that. Something that we know just by looking at it is that the angles are all right angles. So we can say a rectangle has all right angles. And then one more thing that we know to be true is that the diagonals are congruent. They are congruent, they're the same length. So if I had a diagonal here and I just wanted to move it, and turn it around, it would be the exact same length as this diagonal here. So those diagonals are congruent. Now we're going to look at today are rhombi and squares. Now rhombi is just the plural form for rhombus, but let's keep looking. So if we have, I'm going to use a different color here, and this is maybe something you'd want to take notes of. So squares. Something that we know to be true of squares is that it has 4 congruent sides, right? So it would say all sides are congruent. That's something special about a square. They are all angles would be right angles, just like a rectangle. And if we look at a picture of a square, all our lengths would be the same. So these are all the same. Something that's interesting about the bisectors is that the bisectors, sorry, not the bisectors, the diagonals. Something that we see about the diagonals is that they actually also form 90 degrees. Diagonals are perpendicular. That's a new one. That's not one that we've seen before. So diagonals are perpendicular. That is something that is unique and specific to a square. And so they're perpendicular and the diagonals bisect a pair of opposite sides, opposite angles. So meaning that if I had my sorry, I'm pulling up my whiteboard here. The diagonals bisect the angles, the opposite angles. So like if I had an angle here, this was 90 degrees, these are split into two congruent parts. And so this diagonal bisects the opposite angle. So something that's kind of cool about squares and rhombi is the squares have all the same qualities of a rhombus as well. So let's take a look at a rhombus. I'm gonna maybe fill that out over here. Rhombi as plural. So a rhombus has all the qualities of a parallelogram. It doesn't have the same qualities of a rectangle. It doesn't have the same qualities of a square because it doesn't have 4 right angles. But really a rhombus is like a squished square. So if we draw a picture, a rhombus is like a square that's been kind of stepped on, maybe like just squished a little bit. So all these sides are the same. And it has the qualities of a parallelogram. So a rhombus has all the same qualities as a parallelogram. The two things that are different from a parallelogram is that it has diagonals also form 90 degrees. So the diagonals are perpendicular. And it has 4 congruent sides. So we're going to say diagonals are perpendicular. And another thing is that the diagonals bisect opposite angles. So this is something that's unique to a rhombus, and it's the same as a square. So if I had a diagonal here, use it in orange, and it cuts through, it actually slices through and creates the same measure for these two angles. It bisects the angles. And same here, if I have a diagonal cutting through here, these are bisected. Okay, that's not necessarily true about a parallelogram because these angles might be different. Okay, they would be alternate interior. They would be the same if they were alternating, but not next to each other. Like these two angles would be different. And so two new things that we know about a rhombus is that diagonals are perpendicular and diagonals bisect opposite angles. So let's take a look at our study guide. So here we can also see that the two things that are new to a rhombus is that diagonals are perpendicular and each diagonal bisects a pair of opposite sides. And so a rhombus is a parallelogram and it has all the properties of a parallelogram. So looking at this picture, you can even see that these angles here are bisected, they're the same. These angles are the same, and then it has all 4 congruent sides. And also the diagonals are perpendicular, it creates this right angle. And so for a square, if we look down here, it's a parallelogram with 4 congruent sides and 4 congruent angles. A square is both a rectangle and a rhombus. Therefore, it has all the properties of a parallelogram, rectangle, and a rhombi. So basically, the square has all the qualities of everything we've looked at up until this point, which is a lot of information, right? So if you look through your flip book, there is a page. You see this. This is your flip book. There is a page here that has a list of all the qualities of a square. If you can list out all these qualities without looking at your other pages, then you literally know the qualities of a parallelogram, you know the qualities of a rectangle, and you know the qualities of rhombi. And so that would be literally all the qualities we've learned up until this point, which is pretty cool. So looking back at our study guide, we're just going to do a few practices where we find the missing piece. Now be very careful because it's asking us to find actual measurements of certain parts. So let's look at this picture. We're going to use this picture as our reference, and it says if ABD is 60 degrees. So we're going to go follow ABD. That would be this angle right here. If that's 60 degrees, find measure BDC. That would be this angle. So if you look at this, this is the diagonal. It's cutting through, and we know that these two angles that's cut by the diagonal makes congruent angles, and so that would also be 60 degrees. We don't even have to measure it or find it. And then if AE is 8, find AC. So if this part was 8, what would this part be? Actually, what would this entire length be? Well, EC would be 8, right? They would be congruent because that's what we know. That's something we know to be true about a parallelogram. So this has the qualities of parallelogram. So AC would be 16. Number 3, AB is 26. So AB is right here. That's 26. Find BD is BD is 20, and it's saying find AE. Okay, now this one takes a little bit more creative thinking, I believe. So let me take off all this stuff. So AB here is 26. This whole thing is 20. And we're looking for, I'm going to use green to show what we're looking for. We're looking for AE. So the question is, how do we find this? Now, here's the thing. Isn't this a right angle? So if I look at all the lines drawn on here, this is a right triangle. So let me separate this out. This part's 26. Now, what would this length be? If the whole length BD would be 20, what would half of it be? Well, this would be 10, wouldn't it? So that means we just need to find this side. We can use the Pythagorean theorem. So we can use what we know about the Pythagorean theorem, that the legs squared added to each other equals the hypotenuse squared. So 10 squared plus question mark squared, let's say x, equals 26 squared. So this would be 100 plus x squared equals 26 squared, which is 676. So if we subtract 100 from the other side and square root 576, that would be 24. So x equals, well, let's show all our work. We're going to square root both sides. X equals 24. So AE is 24. We just found that. Number 4, it says find the measure of CEB, this angle right here. Well, we don't even have to do anything. CEB, we know, has to be 90 degrees. Looking for if CBD is right here, that's 58 degrees. Find ACB. ACB. Okay, Now, again, we've got some information. We're looking for stuff related to triangles. So let me draw this triangle out here. It says this angle here is 58, and we're looking for this one. Now, how many degrees is this angle again? That's CEB. That's 90 degrees, isn't it? So what do we know about all the angles of a triangle added to each other? We know that it has to all add up to be 180, right? So if we do 180 minus 90 minus 58, that would give us the remaining measure of our third angle, and that would be 32. So that would be 180 minus 90 minus 58, and that equals 32. So guys, here we're really applying a lot of information we know from previous lessons, things that we've learned before. This is all just stuff that we know in our memory chip that we are aware of and we're using, okay? So number 6, if AE is 3x minus 1, so that's this length, maybe I should use a different color here. AE is 3x minus 1, and AC, the entire length, is 16, find x. So first let's think about what's the relationship between AE and AC. Well, isn't AE just half of AC? So that means AE, if the whole length of AC is 16, then half of that would be 8. So AE is also 8, right? The length is 8. So then we can just set up our equation as 3x minus 1 equals 8, and then work this out to find x. Add 1 on both sides, then divide by 3, x equals 3. Okay? I know it's getting messy. Let's take a look at 7. CDB, that's right here, that's 6y. And ACB is 2y plus 10. Okay, I think I might have to draw this picture out on the side because we're just getting so crammed, or maybe I'll just go back and take all this stuff off. So I want you to think about, maybe pause the video and think about how you would find that missing part, that y there. Still very busy, isn't it? Okay, I think this is a little bit better. Okay. All right. So let me label this. CDB is right here. That is 6y. ACB, that's right here. That's 2y plus 10. And we're trying to find y. We're trying to look for this. Okay, so if I know that this part here is 2y plus 10, if I use a darker color, what would this angle be? Wouldn't it be the same? Because we know that these two angles are bisected by the diagonal, and so these two angles are the same. So that means this angle would also be 2y plus 10. Okay, so knowing that this is 90 degrees, because that's always going to be 90 degrees, what's the relationship between all these angles? Well, wouldn't it be 90 plus 2y plus 10 plus 6y? So basically what I'm saying is angle C plus angle D plus angle E, that all adds up to be 180 degrees. But instead of saying the name of the angle, we actually have a measurement that's given to us. So now we can plug this in. 9 plus 10 is 100. 2y plus 6y is 8y. That equals 180. Work this out. 8y equals 80. Divide by 8 on both sides. Y equals 10. So y equals 10. Now, last problem. If AD, right here, use a different color here, purple. AD is 2x plus 4. And CD is 4x minus 4. Find x. Well, what do I know to be true about these two sides? First of all, this is a rhombus, right? Which means all our sides are congruent because it's like a square that's just been squished. And so this would be 2x plus 4 equals 4x minus 4. And then we can work this out. Let me add 4 on both sides. That would be 8. Let me subtract 2x here, and that would be 2x. So 2x divided by 2, this would be 4, and 4 equals x. And that's your answer. Okay, so really right here, all these questions really challenge you to apply all the information you know, all the qualities you know of these shapes. If you don't know the qualities, you won't be able to find it because you have to set them up as equations where you can find that. Now, looking at the back, here's the thing is, with our coordinate planes, remember we talked about we're not doing any more coordinate planes with these other shapes. We're only doing coordinate planes with parallelograms and rectangles. And so with this, really what I'd like for you to do is plot them down. And we're not going to look at slope, we're not going to look at the distance and all that stuff, but I want you to plot it down, look at what you see on your picture, and then make a prediction of what type of shape it is and why. So give me the qualities that you see about this shape when you plot it down and describe why it's that. So you're just visually looking at it and describing, oh, this is a parallelogram because I know that not all the sides are congruent, but I have the qualities of a parallelogram. You might list them all. Or you might say, oh, this is a square because all 4 sides are congruent and it has 4 angles, 4 right angles, and the diagonals create perpendicular angles, something like that. So when you look at this, you can describe the qualities. So I'll do number 1 with you. My drawing's not going to be perfect because I do not have graph paper right here, but I'm just going to plot this down. So 0, 2, label your points, 2, 4, 4, 2, and then 2, 0. Okay, so looking at this, it looks like a square. You might not be completely accurate, but you're going to decide. I think this is a square. And you're going to list out the reasons. It has 4 congruent sides and maybe 4 right angles. They look like they're right angles. It could be a rhombus. We don't know for sure. My drawing might not be perfect. But you'd give a few qualities to kind of explain why you think that's the shape it is, just to practice reviewing these qualities. And that's all I'm asking you to do here, okay? If it doesn't look like any of those shapes, describe how it's not any of those because it doesn't have those qualities, okay? And that's all I want you to do. You don't need to do this proof. And so this lesson is much shorter than the other ones because we're not going to look at the coordinate planes. So that's all I have for you today.